Okay, so I guess I want to talk a bit about question 9. So question 9, I think maybe we'll talk about question 8 afterwards, and I want to also talk a bit about cutoffs. So question 9 is one of those questions is that it looks really hard, and then it kind of looks really easy, and then you're done, and then you get it wrong. Yeah, so you have a sequence of real numbers. And so the fact that the sequence is real numbers is also it's already suggesting it's a question that's intended for like year 9 and 10 students, because you don't really learn about real numbers until towards sort of that time, towards the start of HSC. Um, so it's a real sequence, and it has two conditions: non-decreasing, and it has the condition that um, A3n. Wait, was it this? 5 times AN? A2n equals, I think it was the other way around. So it was A2n equals something times AN, and A3n equals something times AN. Can you remind me what it was? Was it
So I think it was A5N. It was A5N, right?
A5n, yeah? No, I think it was one of them was a multiple of 5, but it was A3n. Yeah. Yeah. All right, thanks for that. So these are the two conditions, yeah, and we were trying to find all sequences. Okay. So funny little story. When I looked at this, I was like, oh, I didn't even see that it was non-decreasing. Okay, so let's just omit this, and I went on to solve the problem without that condition, and it's not actually too difficult, right? So what the condition tells you, so what this condition tells you is that once you know like A1, right, then it determines like A3 and A9. These are all determined, you know. Okay. Similarly, all the powers of 2 are determined, right? Um, and actually, so if you have any power of 2, so if n has, so let me introduce some notation. So the power of 2 that lies inside of n is called the nu 2 of n, yeah? So basically, if nu 2 of n is positive, so if there's 2's in the n divided, if n is even, right? Then it's going to be determined by something with less 2's in it, yeah? So it's ultimately determined by something with no 2's in it and no 3's in it, right? And actually, you could define them to be whatever you wanted, okay? So if that was the question, then the answer would be sort of assign sort of a, so an equals, so you can assign anything basically when if n has no 2's and 3's in it, you know? You can assign anything. And otherwise you have to assign the right multiple of the things that don't have any. So otherwise 3x or 5x above, yeah? So it's actually a pretty straightforward condition, but it may be hard to think that generally. And I was like, wow, this seems like a pretty tricky question for AIMO, and then I realized, oh, it says non-decreasing, which I think makes it much simpler. So non-decreasing just means that the constant could be the same as the previous term, but it can't be more, it can't be less than the previous term. Yeah, it has to be more or the same. So actually, if you kind of just did some basic calculations, so, and by basic calculations, I guess, I mean these kind of things. So like A3 would just be 5A1, yeah. A9 would be 25A1. And A2 would be 3A1. Um, 3A1, 9A1, 27A1. Okay, and once you got to this point, you'd be like, oh, wait a sec. 27 is bigger than 5, right? So that seems like to be a problem because it seems like A8 and A9. So there seems to be a problem here. So A8 is supposed to be less than or equal to A9, right? Or is it? But A8 at the same time is equal to 27A1. So 27A1 is supposed to be less than or equal to 25A1, right? So if 27 is A1 is equal to less than or equal to 5A1, the A1 needs to be negative, yeah? Okay, I think a lot of people would have missed that it could be 0. Maybe I'll put a poll. Did people miss that it was could? Did you get that the 0 sequence was a solution or not? Yes, if you did. No, if you missed the 0 sequence. Okay, so one way to cut, like when you do this a bit more, you'll start realizing 0 has to be a solution because these were called homogeneous conditions. Okay, so you're just scaling kind of scaling stuff. So if everything was 0, it would be consistent. Okay, and then can you see why A1 cannot be negative?
Because of the previous terms, if it was negative, then it would be decreasing.
Yeah, so like A3 is equal to 3A1, right? And that needs to be bigger than or equal to A1, right? So it can't be negative. Okay. Um, okay, and then you say that 0 is the only sequence. Is there anything wrong with that? Okay, so 4 out of 6 got that 0 was a sequence. Okay. So let me ask one more question. Is my proof complete? So if I said 0 is the only sequence and I said QED right now, is my proof complete or not? It's only one person's voted. I guess it's much easier to vote no than yes because in some sense, if you find them, if it depends if there is something wrong and you find it, you can see it right away. But if it's yes, you have to see that there's nothing wrong. But okay, so I don't know, depending on who the markers are, I don't know if I should get full marks or not, but the proof is certainly not complete. Um, so I've said 0 works, and I've said A1 has to be 0, yeah, but the conclusion from that does not mean 0 is the only sequence. Like, it could be true that 0 is the only sequence, but the reasoning hasn't established it. Alright, can someone suggest what's wrong with the proof if it's not complete? Or maybe how to complete it even? Okay, so the thing is, once I say A1 is 0, right? I get that, A3 is 0. I get that A2 is 0. I get A4 is 0, but I don't get A5, okay? I get A6. I don't get A7. You see what I'm saying? So it doesn't prove that all the terms are 0, right? So there could be so there's two ways to maybe fix this. At least two ways, I guess. Any ideas?
Induction or like each power of 5 like is 0, that like refreshes, like that makes every time before like equaling to 0, and then powers of 5 go on forever.
Okay, so what I understood from that was because powers of 5 kind of, so you have A1 is here, that's like a power of 5, and then you have some other power of 5 here, and maybe not powers of 5, powers of 3, you mean? Or powers of 2?
Yeah.
You know that they're all 0, right? So if it's non-decreasing, then the terms in between all have to be 0 as well, right? So that's one way of saying it. So terms between zeros are 0. Another way of saying it is you could just redo the original argument, right? So instead of doing A8 and A9, you could do A8M and A9M, right? So let M be arbitrary. 8M, so 8M should be smaller than or equal to 9M, but this is 27 AM. This is 25 AM, right? So therefore AM, because it can't be negative, because the first term is positive, for example, it has to be 0. And since M was arbitrary, it has to be 0 for all M. Yeah. Yeah, so did you like that proof? Okay, so here's the new poll. Okay, excellent. Yeah, so I think you would get like so if you got the 0 sequence, I think you get 1 mark at least, probably just 1 mark. If you got the argument with A8 and 9, I think you should get at least a mark. So the A8 and 9 thing, I would, if I was marking, I'd probably give 2 or 3 marks. But it just depends on what you can. So like the A8 and 9 thing would be missing this step and the 0 sequence thing. Um, so whether you thought that was worth 2 marks or 3 marks missing, yeah. Okay, so I kind of also want to discuss cutoffs before I give it over to Yi. So we have